So welcome back to the channel. I'm Paulo Shakarian, and this is our third and final part of our interview with Luciano Serafini and Sami Badruddin, two of the co-authors of Logic Tensor Networks. So in this part of the interview, we'll talk about, sort of the future of AI, kind of some broader ideas, specifically artificial general intelligence. Many people believe that neurosymbolic AI represents something that can really help push our field toward artificial general intelligence. And maybe start with Luciano. What are your ideas on how neurosymbolic AI and neurosymbolic reasoning would contribute toward the goal of AGI?
Again, I think that we go back to the big problem of symbol grounding. Okay, so AGI cannot be done without the symbol grounding problem. As I intended, AGI is the possibility, as far as I know, of building up an agent, a general agent that is capable to to behave intelligently in an unknown environment. So the agent needs to be able to acquire autonomously knowledge about the environment. And as John McCarthy says in the initial paper about artificial intelligence, there is no knowledge without being able to express this knowledge with some symbolic method. So symbol grounding is important, knowledge is important, and communication of knowledge is important. So once you have communication of knowledge, how another agent can use the knowledge and not to learn it directly from scratch. And here is where neurosymbolic integration is important. You have to put together the knowledge that somebody else communicates through symbols to you, and the knowledge that you acquire by looking and experimenting the world. And this is necessary. Otherwise, if all the knowledge comes from data, then every single agent will have to learn its own knowledge, and there will be no exchange of this knowledge via communication. And in particular, for example, if you take the achievement of GPT, of big language models, if you want to build up an agent, a general agent, that use the knowledge, this knowledge that can exploit some general knowledge, this knowledge can come from big language models. Okay, so you can use it. And I think that general artificial intelligence cannot be completely separated from, it's tightly connected, let me say, to embodied AI, where the idea that one agent has a body and has an interaction with the real world. And so it has internal symbols, they are connected with the real world. Knowledge is acquired also via acting. And this, I think, is the new thing that we should add also to neurosymbolic integration, which is acting to obtain new experience and to learn more the connection between symbols and perceptions.
Oh, I think that's really interesting. I think there's some people in the cognitive science who talk about the process of transduction, which the translation between neural architecture and symbols, and part of the way that is performed is through action, is through kind of this repeated reinforcement with the outside world. So maybe, Sami, I wonder if you kind of have an opinion on kind of AGI and the role you see neurosymbolic AI playing in evolution here.
I believe neurosymbolic AI may be one of the easiest way to get to AGI, because so far we have all those like very specialized AI in many different tasks, and Neuro Symbolic AI may be an easy principle solution for combining those specialized models without retraining something from scratch to get to a general intelligence, a bit similarly to what Luciano says. I believe technically it's possible to build something end-to-end to make a general intelligence with huge data, huge resource, but there's also the question of, other than for the gimmick, is AGI that interesting? Do we need a model that does everything at the same time instead of like many specialized models? And I'm not sure we need it for so many things, so we need an easy way to get there if we want to try to get there.
I think that's, I think the comment about, do we really need AGI, or is everything going to be specialized? I think that's a fair one. On the other hand, I think that Luciano's comment about the interface between agents that could give rise to, AI that could maybe be more modular, maybe the future of AGI is, maybe along the lines of something more modular. I mean, what are your thoughts on that? Do you feel that as an industry guy, do you feel that kind of the current way AI and machine learning work is good enough for engineering purposes? Or do you think that this modularity, these ideas of symbolic interfaces are going to be required going forward?
Yeah, I definitely think so. That modularity is so the point I was trying to make is that if we don't rely on modularity, then we need to invest a lot of resource to build those general intelligences. And relying on modularity would reduce that by a ton and make it actually worth it to explore. So yeah, I definitely think it's a good idea.
So, so one thing so Henry Kautz introduced this taxonomy in a talk he gave at AAAI several years ago, where he had, different classifications of neurosymbolic systems. And the highest level, he talks about the embedding of a combinatorial reasoning within a neurosymbolic architecture. And he hints a little bit that this is a key, something that he felt would lead to perhaps AGI. In my view, there hasn't been a whole lot of work that's been directed toward this. What are your thoughts on, doing very sophisticated reasoning tasks that may require, combinatorial type algorithms to take care of that within the context of a neural architecture?
I don't know. I mean, I can express a very polarized opinion, but well, I think that combinatorics, I mean, current computers are much better in combinatorics than humans. So my point is on trying to implement combinatorics into a neural networks. I don't understand why. I mean, I don't understand what's the main goal, why one should do this. The only reason that I can see now is just to have approximate results in combinatoric when you have large problems. But we are, as humans, we are not very good in combinatorics. Still, we are intelligent, most of the cases. Okay, so I don't know if I'm a bit kind of confused about this type of argument and research line.
I guess I bring it up because I think of things like the argumentation process and defeasible logic, abduction queries, deduction in certain logics that are end up being combinatorially expensive, and there's been a lot of work kind of more on the logic side or on the symbolic side on these things, but they haven't, many of them have not been fully integrated into a neurosymbolic approach. And so when Kautz mentions that, I kind of wonder, is that a step that we need to take, or is it something, or does it look like something different?
Okay, maybe I misunderstand what you mean and what you report, because I was thinking that you do the combinatoric inside the neural network. What I'm thinking is that all the work that has been done in all the fields that you mentioned about abduction, but even probabilistic reasoning, okay, there is a lot of combinatorics.
Yeah, of course.
But that type of reasoning should stay there. And the point is that you have to integrate this reasoning with some neurosymbolic, with some neural network, but not to replace this reasoning with neural network. That was my point.
Oh, yeah. So I think that I probably would agree with. Yeah, I mean, to clarify, I meant integrating that into a neurosymbolic architecture. So
okay.
Yeah.
In that case, I agree. At AAAI, I was talking with other researchers on the possibility of having a neurosymbolic integration where the logic is non-monotonic. Okay, so the logic part is non-monotonic reasoning, default logic, and things like this.
Mm-hmm.
Is there anything around about this? No, as far as I know. Maybe yes, but I don't know. I'm not aware of anything like this, and it should be interesting to see.
No, I think that would be. I think
There will be. Mm-hmm.
So. I know we're coming up on time, but I'll just end the conversation with one fun question. Is what would be your prediction on how far in the future we'd see something that we would be able to call AGI?
Sami, you answer this difficult question.
Hey, it's YouTube. We got to ask questions like this once in a while.
It's like a bet. I think in the next decade we're gonna get to a first modular AI, as we're talking about. That's my intuition.
Luciano?
I think, well, every 10 years something comes out. So yeah, perhaps the next general artificial intelligence will come in 10 years. I agree with Sami. Let's see what's going on. It will be something like ChatGPT, but general intelligence on larger space.
Okay. Well, we'll follow up in 10 years and watch this video together and see if we're right. So,
yeah.
Well, hey, thank you both. I appreciate you taking the time. And this was a fun conversation. So, thank you very much.
Thank you to you, Paolo.
Right.
It was really a pleasure. And thank you for organizing all this channel.
No, my pleasure.